Hello YouTubers and fellow hams. Well, this video is going to probably be a two-parter. I'm going to be doing an experiment. It might even be a three-parter. I don't know yet. But I thought I'd do this one a little bit differently. A lot of times with my experiments, I fiddle around with whatever it is that I'm experimenting with, gather some data. By the time I start filming, I already know some of, whether this is going to work or not. And yeah, usually I don't film on the failed experiments because I do a lot of experiments with just silly stuff, just ideas, and I wonder if this will work, I wonder if that'll work, and I try this and I try that, And so this one's going to be a bit different. I'm going to bring you along with me on the entire experiment. Success or failure, either way, you're going to see, does this work? So this might be 3 videos of a failure. But hey, that's how it goes. Experiments are experiments. So what I'm experimenting with? Well, a little while ago I built a folded dipole. I made it out of ladder line or window line, twin lead, and it was quite successful. It's a standard folded dipole, nothing very special about it. It was the first one that I've built since I read about them years and years and years ago. As one of the comments in that video echoed a thought that I also had, can you feed it from the end? We all know that one of the current crazes are the end-fed half-wave wire antennas, where you take a wire antenna that is a half a wavelength and it is fed at the end with a 49-to-1 auto transformer or unbalanced to unbalanced match. These are quite popular right now. It seems like these crazes come and go. It was about 5-6 years ago, 9-to-1 on UNs and end-fed wires was the craze, and there were resonant and non-resonant versions. And I like the non-resonant versions because you have to use a tuner, but you can tune them on most of the amateur bands. With varying lengths of wire, you can get an antenna up that will get you on the air on most of the bands. Not the best performer on any individual band, but just sort of a general get me something up to get me on the air antenna. The end-fed half-wave antennas are resonant on a specific band, but can be tuned on other bands with okay performance. Again, not optimal. So the folded dipole, somebody asked if it could be end-fed. I don't know. I went out and started looking, and I could not find any examples in any literature of such a beast. So I started thinking about it in my head. There's questions of impedance and so on and so forth, and we'll get to that in a moment. So that's what this experiment is going to be. I'm going to attempt to build an end-fed folded dipole, if it would even be called that. Maybe it would be called a shorted stub. I don't know. Using ladder line or window line and some kind of an impedance match depending upon the impedance at the end. So that's what we're doing. Let's go down here to the bench and a piece of paper, and I'll draw up some diagrams for you, show you what I'm talking about. All right. I'm going to do a big Clive.com thing here and do some drawing. So the antenna, as I said, it's going to be a folded dipole. Now, a regular dipole, if we look here at a reference from the Practical Antennas Handbook, you'll see he shows that the impedance at the center of the dipole at its resonant frequency is 73 ohms. Now, this is if it's in free space, and if the dipole is a little closer to the ground, like most of our dipoles usually are, you'll have closer to a 50 ohm impedance, because the closer you get to ground, the lower the impedance goes, I think. Yeah. So anyway, I have always heard that at the end of the dipole, the impedance is about 1K. In the Practical Antennas Handbook, Mr. Carr says it's 2.5K at the end. But yeah, I don't know. I know that the end-fed half-wave antennas use a 49-to-1 match, And 49:1 the folded dipole, you know, if we look back at the diagram, at a diagram from the antenna handbook again, he shows a nice picture of a folded dipole, and you can see that it's basically a squashed loop, just a connected loop. It's connected from the center to the shield of the coax if you're using coax, but you'd need to use a balun, because on a folded dipole the impedance at the center is going to be around 200 ohms, and then a 4:1 takes that down to 50. I don't know if the impedance at the center on a folded dipole is directly related to and changes with the impedance of the ladder line that's used if you're using ladder line. I'm sure that it does, but every folded dipole design that I have found uses a 4:1, which would indicate a 200 ohm impedance at the center, so that's interesting. But what about at the end? So what I'm going to be doing is I'm going to be taking some ladder line. All right, and this is ladder line, so it's got the supports keeping it parallel. And at this end, these ends are going to be tied together, okay? And instead of feeding it at the center, we're going to feed it at the end. So what's the impedance going to be at this end? I don't know. Is it going to be like a standard dipole and just be around 1K? Is it going to be the impedance of the ladder line? I don't think so, because we're going to be measuring it at a resonant frequency, right? And yeah, I'm going to cut it for 20 meters, so it's going to be around 33 feet. And what I'm going to do is at the end here, I'm going to hook the VNA up just to the ladder line and measure the impedance at resonant frequency. And then that will give us a number, and then I can figure out how to match this to coax. Because what goes here, we don't know yet. So that's going to be the first step. Cut the ladder line resonant for 20 meters. Scan it and see what the impedance is. Once I know this impedance at the end of the wire, then I can focus on what I need to do for a match. Now, if it is like with a regular dipole close to a K, then I might use an existing 49:1 design in here. And that should bring us down to 50 ohms for the coax. Now, if this works, it'll be a really nice antenna. It'll be a nice antenna for one big reason, and that is deployment. With an end-fed antenna system, you know, you got a tree over here, and you're set up over here. You can put a stake in the ground, and you could just run your antenna up to the tree, you know, with a single anchor point up here. You throw a line over the tree, pull it up. That's why end-fed antennas are nice. They're easy to deploy in the field. And if this end-fed folded dipole works, we'll get all the benefits of a folded dipole. It'll be low noise. Boy, I can't write for crap this morning. It'll be low noise. It'll be high performance. And really easy to deploy. So what about this end point, the feed point? Now, in previous videos, I've 3D printed structures. I've designed them in Onshape to get exactly what I needed, and then 3D printed it. And you know, that's just convenient for me. But what about somebody that wants to put something up more permanently? You'll need a different material, and I have found a really good material. This is a nylon cutting board. It's about 1/4 of an inch thick, a little bit flexible but plenty strong, and nylon's a good material. And you can get these pretty cheap. This one was 88 cents, I think, at Walmart. So yeah, you can get these pretty cheap, and that's a big block of material that I'll be able to cut things out of to use. So I'm going to use this nylon as my feed point. So the feed point you're going to have the ladder line coming in. And what I'm going to do is I'm going to cut a block of nylon, like so, and the ladder line is going to be anchored to it. And then I'm going to have a couple of terminal points here that it'll connect to. Enough space here for a ballon, right? And then I'll have a hole over here for the coax connector. So, and well, actually this will be closer because there'll be another hole or maybe a couple of holes here for anchoring this end of it to a stake in the ground, to your bumper on your car, to whatever you're using to anchor this end. Coax connector here. So from the side, the ladder line will go off this direction. You'll have your coax connector here with its connections coming up here to the ballon, and then that'll go to the antenna. So the coax will come off at a right angle from this, which is good, because if, let's say you had your antenna deployed vertically, that would mean your coax would come off like this to go to your antenna, or go to your transmitter, so that would be convenient. It comes right off to the side. If you have your antenna horizontal, suspended between, say, a tree over here and a tree over here, then your coax would just drop straight down to wherever you're hooked up. So, and if it's set up as a sloper, then your coax would be coming off the side of it, right over to your transmitter, you know. So that is the plan. First step is build the structure without the ballon. Just hook the connector straight to the antenna, and then I can hook the VNA up to it, and I can scan it and find out what that impedance is on the end-fed ladder line antenna. And then after I've done that, I can then design or figure out what to do for a matching network to bring the impedance down to 50 ohms, and then the antenna will be done and we can put it up and test it. So that's where I'm going from here. I'm going to start by measuring things out with my ladder line and just cut out this nylon, drill the holes, get everything mounted there, get my mast up so I can pull the ladder line up as a sloper, and then measure its impedance, and we'll go from there. So that'll be the next video. The next video will be building it all, scanning it with the VNA, figuring out that impedance, building the match network if it's needed, and then testing out the antenna. So this should be just a two-parter. Anyway, we'll see you in the next video, and we'll get this antenna put together. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.